Welcome to Knowledge Gainer 1M channel. Today our topic is LCM, least common multiple, or we can find the LCM by taking all the bases with highest power. Now let us see the first question. Find the LCM of 18, 24, 60 and 150. We should write all the prime factors of all the numbers here. After doing this method, now the factors are 2 power 3 into 3 square into 5 power 2. The LCM is 1800 for 18, 24, 60 and 150. Now let us see another method. LCM of, second question is LCM of 90, 120, 240. Now by finding all the prime factors of these three numbers individually, we get prime factors of 90 is 2 into 3 square into 5. For 120 it is 2 power 3 into 3 into 5. For 240 it is 2 power 4 into 3 into 5. Now to find the LCM, we should take all the bases with highest power. What all the bases are there? 2, 3, 5. With highest power 2, 2 power 3, 2 power 4. Take 2 power 4. 3 square, 3 and 3. Take 3 square. 5 power 1. Here the LCM is 720 for 90, 120 and 240. Third question is LCM of 0.6, 9.6 and 0.36. In this case, first we need to remove the decimal points. Then we can do in the first method or in the second method to find the LCM. To remove the decimal point, we should move the decimal point 2 times to the right. Now the numbers are 60, 960 and 36. LCM of 60, 960 and 36 can be found from the first method or from the second method. Now the LCM is 2880. But we should find the LCM of 0.6, 9.6 and 0.36. So the LCM of these decimal values is, we should move the decimal point 2 times to the left. So 28.80 is the LCM for the given decimal values. HCF, highest common factor. It is also called as GCF or GCD. Greatest common factor, greatest common divisor. Let us see an example. HCF of 343 and 1470. In the division method, 343 4 times is 1372. 98 is the remainder. Now take this divisor to here. 343 4 times is 294. Remainder is 49. Take this divisor 98 here. 2 times is 98. Remainder is 0. Here 49 is the HCF for 343 and 1470. Fifth question is HCF of 1365, 1560 and 1755. Here these are the prime factors of these three numbers. HCF is common base with least power. We should take only the common bases. Here 3 is common for all these three numbers. So take 3. But take with least power. Least power is 1. Into next see 5. 5 is present in 3 numbers. So take 5. Least power is 1. 7 is not common. So remove 7. 13 is common. So take 13. Least power is 1. And check 2. So 2 is not there in first and second. So remove 2. So 3 into 5 into 13 is 195 is the HCF for the given numbers. Sixth question is the greatest weight which can be contained exactly in 1 kg 235 grams and 3 kg 430 grams is. Now we should write this in single units. So 1 kg 235 grams is 1235 grams in total. 3 kg 430 grams is 3430 grams in. The greatest weight which can be contained exactly means we should find the HCF of 1235 and 3430. Now the prime factors are 5 into 13 into 19 and here 2 into 5 into 7 cube. We should take the common factors with least power. Here the common factor is only 5. So 5 grams is the greatest weight which can be contained exactly in the given weights. Let us see the note points. LCM of the given set of prime numbers is their product because they have the common factor as only 1. HCF of the prime numbers is 1. Product of two numbers is equal to the product of LCM and HCF. LCM of fractions, LCM of numerator by HCF of denominator. HCF of fractions, HCF of numerator by LCM of denominator. But all these terms should be in the lowest terms only. Seventh question, LCM of 4 1 by 2, 3 10 1 by 2. Now we should write this in the lowest terms. So 4 1 by 2 is equal to 9 by 2, 3 and 10 1 by 2 is equal to 21 by 2. Now the fractions are 9 by 2, 3 and 21 by 2. Now to find the LCM of these fractions, we should find the LCM of 9, 3 and 21 by HCF of 2. The denominator is 1 here, 1 and 2. LCM of 9, 3 and 21 is 63. HCF of 2, 1 and 2 is 1, which is equal to the LCM of the given fractions is 63. Eighth question, HCF of 54 by 9, 3, 9 by 17 and 36 by 51. Now we should write this as 55 by 9 is 6 by 1, 3, 9 by 17 we can write it as 60 by 17, 36 by 51 is 12 by 17. Now we should find the HCF is equal to HCF of 6, 60 and 12 by LCM of 1, 17 and 17. So the HCF we get as 6 by 17. Least number exactly divisible by 8, 12, 15 and 21. Here we should find the least number. So the required number we get is LCM of 8, 12, 15 and 21. The factors of 8 is 2 power 3, 2 power 2 and 3 is for 12, for 15 it is 5 and 3, for 21 it is 7 and 3. So we get the LCM. All bases with highest power. So 2 power 3 into 3 into 5 into 7, which is equal to 840 is the number which is least number exactly divisible by these numbers. Note point, if HCF of two numbers are given, then the two numbers can be taken as HCF into A and HCF into B. Here A and B must be coprimes. Let us see the definition of coprimes. Coprimes, a pair of numbers whose common factor is only 1. Here all the prime numbers are coprimes, but all the coprimes are not the prime numbers. Let us see some examples. Let us see 2 and 12. The factors of 2 are 1 and 2. The factors of 12 are 1, 2, 3 and 6. Here 1 and 2 both are common for 2 and 12. So not coprimes. Let us see another example. 3, 8. Here the factors are 1 and 3. Here the factors are 1, 2, 4 and 8. So the common factor is only 1. So coprimes. 3 and 8 are coprimes. 10th question. The LCM is 7700 and HCF is 11 for two numbers. If one number is 125, find the other number. From the note point, we know that the product of LCM and HCF is equal to the product of numbers. So 7700 into 11 is equal to 125 into the second number. Let the second number be x. We can write this as 77 into 100 into 11 is equal to 125 into x. 15.4. X is equal to 677.6 is a second number. 11th question. The HCF is 3 and LCM is 198 for the two numbers whose difference is 15. Find the sum of square of the two numbers. HCF is equal to 3 is given. If HCF is given, the first number be 3 into A. The second number be 3 into B. Here given the difference between the two numbers is 3A minus 3B is equal to 15 is given. So A minus B we get as 5. We know that product of the numbers is equal to product of LCM and HCF. So 3A into 3B is equal to 3 into 198. Here from cancellation 366. So AB is equal to 66. The first number is equal to 3A. Second number is equal to 3B. Now we should find A and B. Here A and B must be coprimes. So 166, 2 times 33, 3 times 22 and 6 times 11. Here all these are not coprimes. Only 6 and 11. These have only 1 as a common factor. So take A as 6 and B as 11. So the first number is 18 and the second number is 33. We got the first and the second number. Now we should find the squares of the sum of the numbers. So 18 square plus 33 square, 324 plus 1089, which is equal to 1413 is the answer. 12th question is LCM is 14 times their HCF. Sum of the LCM and HCF is 600. If one number is 80, find the second number. From the question, LCM is equal to 14 HCF. LCM plus HCF is equal to 600. Instead of LCM here, we can write it as 14 HCF. 14 HCF plus HCF is equal to 15 HCF is equal to 600. HCF is equal to 40 we get. Now from this, LCM is equal to 14 into HCF. So 14 into 40, that is equal to 560 is the LCM. From the note point, the product of the two numbers, first number is 80, let the second number be x, is equal to product of LCM and HCF. So 560 into 40. 2 times x is equal to 560 by 2. 280 is the second number. 13th question. If 4 bells commence tolling at intervals of 6, 8, 12 and 18 minutes, If they start rolling together, find after what interval of time will they together roll again. Here we should find the LCM of 6, 8, 12 and 18. Here we should find the LCM of 6, 8, 12 and 18. The factors of 6 are 2 and 3. For 8 it is 2 power 3. For 12 it is 2 power 2 into 3. And for 18 it is 2 into 3 square. To find the LCM, we should take the common base with highest power. The common base is 2 and the highest power is 2 power 3. And again the common base is 3, which is the highest power of 3 power 2, which is equal to 8 into 9. Which is 8 into 9, that is equal to 72 minutes. So after 72 minutes, all the bells toll together again. Let us see a formula. If two persons are running around a circular track of c kilometers circumference with speeds x kilometers per hour and y kilometers per hour, then after how much time they meet on the track? If they are moving in the same direction, we can find it by LCM of c by x minus y. C is the circumference of the circular track. If they are moving in the opposite direction, we can find it by the LCM of c by x plus y. Now, after how much time again they meet at the starting point? Here, LCM of c by x comma c by y. Here at the starting point means we should use this formula, and on the track means we should use, if in the same direction, c by x minus y, in the opposite direction c by x plus y. Let us see a problem with three persons A, B, C running on a circular track of 12 kilometers circumference. They start their race at the same point and at the same time with the speeds of 2 kilometers per hour, 3 kilometers per hour and 4 kilometers per hour. After how much hours they meet at the starting point again? In the question, after how much hours they meet at the starting point is given. So we should find the LCM of c by x, c by y and c by z. That is 12 by 2, 12 by 3 and 12 by 4. Now LCM of 12 by 2 is 6, 4 and 3. LCM of 6, 4 and 3 is 12. So after 12 hours they meet again at the starting point. So after 12 hours they meet again at the starting point. Please like, share and subscribe to Knowledge Gainer 19 channel and share with your friends.